So in this video we're going to look at assigning stereochemistry to double bonds or alkenes. And we've talked about this briefly before by looking at cis versus trans alkenes, and we're going to move on to looking at Z versus E alkenes. This is just a little bit broader of a description, and it allows us to assign stereochemistry easily to alkenes, even if they don't have symmetrical groups on them. So to assign E and Z, we need to assign priorities to the groups coming off of the double bond. And I'm going to say atoms, because we're going to go one atom at a time. And this is going to be by molecular weight. And the higher the molecular weight, the higher the priority. So it's analogous to what we did when we looked at stereochemistry of sp3 hybridized carbons to assign R or S. The atom with the highest molecular weight will be the highest priority group. So let's look at an example here. Okay, so let's say that I have this double bond. Now it's not symmetrical because I have a methyl on the left-hand side and an ethyl on the right-hand side. But what is true, I'm going to kind of split the double bond in half, and we're going to look at the left-hand side, and then we're going to look at the right-hand side. Okay, so coming off of the left-hand side, I'm going to draw in my H. I have an H and I have a C. Okay, so I'm just looking at the initial atoms that are coming off of that double bond. A carbon weighs more than a hydrogen, so the carbon is my first priority. It's the highest priority because it has a higher molecular mass, and the hydrogen has the second priority. So I was just looking at the left-hand side. Okay, now I'm going to ignore the left-hand side. I'm going to go to the right-hand side. I'm going to draw my H on here. So if I look at this, I have a C coming off the top and an H coming off the bottom. I'm just going to ignore the rest of the chain for right now, and I don't have to keep going because a C weighs more than an H. So here I've got one, and here's my second priority. Okay, so I assign priorities to the atoms coming off the left-hand carbon in my double bond, and then I assign priorities to the atoms coming off the right-hand carbon in my double bond. And I see here that my ones are across from one another, and so that is an E double bond. So now let's look at another example. Okay, so in this case, I've got a double bond. Again, I'm going to split it and look at the left-hand side and the right-hand side, so I'll draw my H in. Okay, so this one looks kind of the same as what we saw last time. H has a lower molecular weight than C, so my carbon on the left-hand side is higher in priority than my H. Now, initially on the right-hand side, I'm going to look at just these two atoms, and I have a carbon in either case. Okay, so there's a carbon right there. Then I have to do a tie break and keep going. Attached to the carbon on the top is another carbon and two H's, so carbon, H, H. On the bottom, I have a carbon, and then attached to that carbon are two carbons and one H. Okay, so this wins the tiebreaker, so this is my number 1 group, and this is my number 2 group. So I do it exactly the same as I did with assigning R and S for absolute configurations on sp3 hybridized carbon centers. All right, you see here that my ones are on the same side, so this is what we would call a Z double bond. Now, we can also have a situation where there is no E or Z stereochemistry, and that is when at least one side of the double bond is symmetrical. So when I go to assign priorities here, I have a carbon, and then attached to that carbon is 3 H's here and 3 H's here. So there's no tiebreaker. These are equivalent in priority. They'd both be 1, so there can be no E or Z. Okay, so not all alkenes have stereoisomers, but if there is an E, there will also be a Z. So looking at what we've talked about, we have the example of E when we have our high priority groups opposite. of one another. So an example of that might be this guy. Okay, my highest priority groups are on opposite sides of the double bond. We also have Z, where the high priority groups are on the same side. So an example of that would be this. So we have our ones on the same side. And then, as we said, not all double bonds have E or Z. So if you have a symmetrical system, so like here I have two H's, since that side is symmetrical, I have no E or Z, because you have symmetry on one or more carbon atoms. But it has to be on the same side. So it has to be on symmetry on the right-hand side or symmetry on the left-hand side.